we are.
There we are, as I live and breathe, and boy, I'm glad I'm doing that.
Well, living and breathing?
Yeah, and breathing, yeah, and sitting upright and
Just one of
getting
those.
around without a cane. Gentlemen, welcome aboard again. Good to talk to the other old talking heads. It is the weekly live podcast for the South Coast Longtime Astronomy and Telescope Society. I'm going to call us a society. The club known as the SBAU. SBAU Astro Hour for the Santa Barbara Astronomical Unit. I do lose my voice from time to time. My name is Ron Heron. Proud to be the host. And this is program number 128. It's going on our third year soon. July 31st, Monday morning, 11 noon. August 6th will be the end of this session as the moon gets ready to fill up. I'm going to introduce you to everybody, but let me tell you what we're going to talk about this hour in our 128th program. We're going to try to make sense out of the latest Webb telescope shots. Talk about telescopes being a time machine. And they got some pictures from 12, 13 billion light years ago, way in the distance. And it's shaking things up. We're going to try to settle this up for you. Checking out the night sky again this week for planets' positions, the full moon, our moon is filling up, stars, a couple globular clusters. Why is the sun's corona so darn hot? Probably the same reason our skin is hot. It's from the sun. It's got the same problem we do. How might we get this? Talk about sci-fi turning into possible reality. Large asteroids could be turned into rotating living habitats. We're going to talk about some of those things with these guys, starting out with our president after all these years, President Jerry Wilson. Jerry, married to Pat.
Good morning.
Good morning. He's also serving as the driver of this temporary webmaster, not the webmaster for the club. That's Tom Totten, but he's no longer with us. Chuck McPartlin is outreach coordinator extraordinaire, who's also married to a Pat. Pat McPartlin is the merchandise manager, and the only thing he's going to report about is all the people that took up the parking lots at Camino Real to see the Barbie movies. Were they showing both of them out there, Barbie and Oppenheimer? Same theater?
Yeah, just Barbie.
And you guys,
Okay.
you guys didn't get a chance to run over there and see it yourself.
No, it's I think it's 2 hours long.
All right. Well, I'm going to ask you for an update sometime this hour on what's going on, what has happened. There's Bruce Murdoch, who's married to Bonnie. Bruce, longtime active member of SBAU, president of the Santa Barbara Theater Organ Society. And he'll tell us if something's going on, only if something's going on. Is something going on, Bruce, with you guys, real quick?
Well, as I said on our previous podcast, that we have an open console typically the second Saturday of the month, but we don't get permission from the theater until like a week before.
You're talking about Arlington.
It comes in and is going to pay them for that Saturday. We get moved to the next Saturday or the previous.
Okay, open console as opposed to the thing under the stage. It's pretty locked up down there, isn't it? I would
That's
imagine.
the organ. We flip the stage. We expose the console, and we don't generally raise it to stage level because we got to undo a lot of ironwork to get it up. But we at least uncover it so that somebody can see it, they can play it, they can hear it. Because the sound doesn't come out of the console at all. All that is electrical contacts.
Okay, how many people in your club?
About 170.
Okay, that's less than we have. I do believe.
Uh,
Hey, there's Tom Whittemore. I
Morning.
smell sourdough bread. He retired from an incredible place we called. Where were you? The Westmont College Science. What was your official duties there? You ran a lab, didn't you?
I guess adjunct professor.
Okay. And I understand the incredible whiff out of your kitchen is toxic, or no, not toxic, but hallucinogenic. Those breads that you bake.
Yeah, it's
Haven't
baguette.
had one. It's really good.
Baguette's
Sourdough, and he's married to Maureen. Bruce married to Bonnie, and we're off and running. Mr. President, you keep us laughing. You send us these silly science cartoons, and we had a dearth of them this past week, but still enough to throw on the screen and get us in the right mood for this hour, talking about heavy duty astronomy stuff. There it is. What do you call an acid with an attitude? Doggone, it's amino acid, not just amino acid. I had something I wrote down for that, but I'm not going to use it. All right, this one is from last week, and I couldn't read it, to be honest with you. I'm going to let you See, none of us can read it.
It's do you have ultraviolet bull? Excuse me. What about regular violet bull? No. Blue bull? No. Green bull? No. Yellow bull? Orange bull? No, no. Okay, I'll just take a red bull.
Okay, got it. Little energy there.
But then you
Yeah.
need to put, the punchline is the next, cartoon, next panel in that cartoon. He was hoping for something a little higher energy. At least it wasn't infrared bull.
Oh yeah. Yeah, I missed the bottom frame.
And here's a Calvin and Hobbes cartoon, a comic from '92, referring to the start of the universe at the horrendous space kablooey. They're calling it that, saying the Big Bang was just too boring. The term horrendous space kablooey, or HSK, has since become popular among scientists and has been used in books and university courses. Is this the one that becomes a sneeze, or is that a separate
No.
cartoon?
That's a separate one.
Oh, okay. Well,
That was last week or last month.
Yeah.
this one,
What am I saying? Yeah.
this one I sent to you, showing what happened to R2D2 and C3PO when they went to Kentucky. Where are we? We're in Kentucky. Look what they became. Cranking it out. The Thunder Road. Remember that? All those illegal stills. My daughter sent that one to me. And
Yeah, they had a movie based on that kind of stuff called Lawless.
really,
Little on the violent side, but a good movie with Gary Oldman.
okay, well.
Yeah.
What? Oh, here's the shark from Jaws. Rare image of it stepping on a Lego. Oh, God bless America! That's the scene we get from Jaws. You know, they got a play about Jaws on Broadway. I kid you
I
not.
didn't know that.
Who plays
There's
the shark?
They have I guess they have the mechanical shark on stage, but it's got the interior of the little ship, and they got the son of Quint, his real life son. Quint, as you know, was eaten by the shark, but he's also passed away in real life. And he looks just like his dad. And it's nothing but the problems they have, or Steven Spielberg had in making the movie back, 50 years ago, in the 70s, 80s.
Yeah.
Anyway, lots to talk about. You want to take on the giant early galaxies or go to the night sky first, Mr. President? Why don't we build?
Let me just
Why don't we build to that?
here. Let me just skip
Still
over
learning his craft and getting darn good at it. Somehow we're on YouTube. You can watch us. Oh, there we go. Those are the 6 different ones.
Yeah, these are the 6 images taken by James Webb that are guessed to be galaxies. They, of course, you can see that they're not resolved. They do get spectra of them, and they do look like galaxies, but they could be a number of things. The simplest explanation is that they're galaxies, but those galaxies would be humongous. And the belief has been that it takes billions of years for galaxies this large, like the size of the Milky Way or bigger, to form, because they form by collision and accretion. So, but here they are, less than 1 billion years old, and they're just as big as galaxies today. So either galaxies form a lot faster then, which is possible, or they're not galaxies, they're something else. So the jury is still out on that.
Or time is dilated.
How do they have a way of measuring the distance based on how far the light is switched to infrared, how red those little blotches are? Is that how they tell how?
Yeah, there's a parameter called Z, or redshift. And at about redshifts of 7, it's back about 12 billion years ago. So these are well higher than 7. So they're objects. So they have spectral lines. Like I said, they do have spectra of these. And they look at them. The James Webb has capability of looking far into the infrared. That's the capability that James Webb is first with, that it has, that's unique.
Do they know?
They can see very heavily redshifted things.
Do they know what that big blob of white is in the lower left picture?
That's a foreground
something-
galaxy.
Yeah, it's something much closer.
it's another galaxy closer to us. It's not a star that's not one of our stars. We wouldn't be able to see it that large. would
No,
we?
it's a galaxy. Yeah, we wouldn't be able to see it that large.
Wow. Well, before we leave this category, gentlemen, someday we're going to have to talk about the big question to me is if that Webb telescope were pointed in any direction, would it probably come across something like this, even though
Yeah.
we're supposed to be looking back at a smaller galaxy that we evolved from, and yet it's all around us?
Run. This has no connection to us. This is just another galaxy that was out there. You can't see your own galaxy in the past.
I didn't say see my own galaxy. I'm saying if we're seeing old galaxies, how come we see it? How does it know to look this direction?
That would be in all directions, Ron. The cosmic microwave background is in all directions.
Really?
Yeah.
And all five of us or four of you guys understand that. I don't.
We are at the center of our visible universe. So
And in
look
fact,
at any
Everybody
direction.
is at the center of their visible universe.
Yeah.
So the idea is
Ron,
that-
if you're standing 30 feet, north of me, you can see 30 feet farther into the universe to the north than I can see. So you're the center of your own universe, and the cosmic microwave background surrounds you in all directions.
Okay, well, I'll accept that.
okay.
Let's
So
go
the
to
idea is that this is the very early universe, and as Carl Sagan pointed out, if you take a movie of our galaxy and you run it, or of our universe, and you run it backwards, you'll see everything starting. It's not expanding. Everything's doing the opposite of expansion. It's contracting. It's going down smaller and smaller and smaller. So 13 billion years ago, our universe was really quite small. So all the matter that's in the universe now was there then, but it's all compact. It's all really close together. So the universe is very different. It's denser, it's smaller, and things happen when matter is denser, that are relativistic. And the relativity of this has been being looked at. One comment is that time apparently was running much slower at that time. So there might be relativistic effects that we're looking at. So just assuming that something we see then is the same as what we look at now may be too simple of a explanation.
But these pictures we're looking at right now were taken the same way the Hubble and the Webb took a deep field. It took a while, didn't it? It had to sit there.
Yes. Yep. Got to collect a lot of photons there.
But the Webb does it much faster. They got deeper than the Hubble deep field. The Hubble took 21 days to take its deep field, and James Webb took 12 hours.
Yeah. The James Webb telescope is much bigger.
But we don't have a deep field feeling with these. They're not scattered all over. It's just
this is a blow up of a deep field picture.
Yeah.
Oh, it is. So
I'll get a deep field picture and show it next week.
I've forgotten how many pixels are in the cameras they have, but they're huge.
Yeah.
You can see the individual pictures and these blow up.
Right. You can count how many pixels are representing that object in the early universe.
It looks like about 10 by 10, something like that.
Yeah, something like that. Yeah.
But we all seen those deep field pictures, and it's a scattering. It's just like a bunch of sand scattered on a floor. And
then this is a zoom into the individual grains.
Yeah, these are the interesting grains of sand.
The six just most distant of all of them in that deep field.
Yes.
Okay.
The reddest.
You suppose they'll ever solve the problem? They think it,
Oh,
Big
yeah.
Bang is.
Absolutely.
You don't have your own theories. They're not quasars.
They could be.
Blazars or quasars, they could be. We don't know. There could be beasts in the early universe that are not supported now.
Quasars basically are long-term supermassive black holes, right? That have gotten so big, they're just too bright and got too much stuff going into them. And
it's not because they're big, it's because they're actively feeding.
Yeah.
Okay. Wow. Fascinating stuff. Well, I'm glad you finally
So
talked
at this
about
time in the universe was almost entirely hydrogen. Of course, it still is, but there was a lot of it. It was really dense. So big stars formed out of hydrogen right away. And because they're big, they're very hot. And because they're very hot, they burn through their helium very quickly. So the lifetime of these stars is fairly short compared to now. So they very quickly became supernovas and blew out all of their fusion products into the universe. And that was type 3, population 3 stars. So there's a lot more subtlety to be discovered here, to be brought into happiness.
Kind of sad though that back then there was no oxygen, but there was nobody around to breathe it, so it doesn't matter, I guess.
It got made rapidly, though.
No oxygen and no water.
That
no.
got made very rapidly too. Once you
Yeah.
have oxygen, you have water, because
Right.
most of the universe is hydrogen.
Well, water
These-
seems to be the
When these
great.
stars started going supernova, you started getting a lot of oxygen and a lot of water.
Water's a strange compound, gentlemen. It seems to be the antithesis of plasma, of everything else. It puts the fire out wherever it is, or turns into gas or whatever. Here we go, night sky.
Okay.
Time, gentlemen, to see where the planets are, starting with what, Mercury?
Yep, this is Mercury. Over the
Venus.
weekend, where is Regulus there?
To the right of Mercury.
There it is, right? It is, yeah. So over the weekend, Mercury came within 1/10 of a degree of Regulus. They're now parting now.
We saw that here with binoculars, Jerry.
Okay,
It's pretty cool.
yeah.
Damn,
So
No, they're
then-
both hot.
okay.
Yeah, Mercury's just moving very rapidly in the western sky, just up and to the left,
Mhm.
up on its way towards Mars.
So this is where we point our telescopes, this part of the sky.
Yeah, it's a little low.
Yeah, binoculars.
Yeah, this is you have to have a really good west horizon, which I do not. There's hills up to about here. And Reagan's Ranch is up about this area from my house.
Huh. Well, you're
So
wrong.
this
Go
is the
ahead.
phase that Mercury is in right now, as it's moving eastward in the sky. It's
Half
just
a Mercury.
past half phase. It's a gibbous. And of course, you won't recognize any of the names of the Maria because these are all names from Mercury. So there's Borea up there, Liguria.
Mhm.
Well, I can't pronounce that one. Solitudo Phoenicius,
Yeah.
Garia, Solitudo Creope. Oh, there's one, Hesperus.
And Australia at the bottom.
Oh, yeah, Australia. Yeah.
There, too.
I'm skipping the easy ones. I like
Yeah,
it
there's-
down.
And Persephone, you see Persephone, she was the goddess that used to go she went underground, and she comes up every spring with all the flowers
Oh,
from the underworld. It's really pretty story.
so we're talking nothing about craters. There's no seas on Mercury, right? No big.
This is talking about regions that are sort of,
Yeah.
it's been divided into.
Yeah. This one
Okay.
up here is a crater. There's 3 real nice craters right here. This is a different structure than our moon. Our moon is basically made out of the Earth's crust, similar composition. This is more like the interior of a planet. It's iron rich and it's heavy and it has a big core.
Didn't they think the outer layers got blown away in the past?
Yeah,
I'm tempted
an
to think
impact.
of that, but yeah, I haven't read that.
And the craters are named after artists and musicians.
Okay.
Wow, really?
I think I was at this guy's performance, Borea. Yeah.
Yeah, like Liguria, Jerry, up in the upper right. That's a beautiful section of Italy where focaccia
Oh.
comes from. I've made focaccia. It's way up north near the
Yeah,
Alps.
yeah, I see it.
Yeah.
Liguria, yeah. Apollonia.
I
Okay.
think I thought I had 2 P's, Apollonia.
So anyway, you can see this in your telescope. Mercury is, you can see the phase, but Mercury is always very low in the atmosphere. So you need somewhere where you have very good seeing,
Mhm.
which we frequently get out at the bluffs overlooking the Ritz-Carlton.
Hmm.
And we had a guy that joined the club, Andy, that was looking for a project, and he decided he was going to image surface detail on Mercury. And the way he did it was by aligning his telescope, but imaging Mercury during the daytime when it was
Yeah.
bright. And that's when you get better seeing. You get more heat effects from the sun, of course, heating up the ground around you, but you can catch Mercury high in the sky when you're looking through less air. And he imaged surface detail on Mercury.
Yeah, with an 8-inch.
Yeah. 8 or 10, yeah.
I think it's an 8, and he didn't make the mirror, but he bought a super duper mirror. I forget.
Okay.
who made-
He inherited a mirror from somebody that was
Yeah.
like 1/30th wave. Yeah.
Now, to cut down on the sun heating the ground around you, it's good to be on grass.
Yeah.
If you're on concrete, you get a lot of heat waves coming up that destroy your seeing.
Why don't you have grass in the bottom of your observatory then?
Oh, well, yeah, right.
He's
Well,
got a
we
roof
will-
over it.
We will never be able to point the Webb at Mercury, will we?
Probably not.
Yeah, I think that's not what it was there for.
But now I'm a little lacking in my Greek mythology. Mercury was a fast dude. He was a runner, I
He
think.
was a messenger.
Yeah,
Is that
Right,
right?
he has
Yeah.
wings on his feet, so Mercury goes around the sun in 88 days. So that's why he got the messenger and fast stuff.
In Greek, Ron, it's Hermes.
Yeah.
Hermes.
Oh, same guy.
Same guy.
Delivering who? To the gods or to the emperors? They didn't have emperors in Greek mythology time, did they?
Pizza, he's delivering pizza.
Yeah.
Okay.
okay. Well, anyway, Regulus is in here, and we have a little chart of Regulus.
Oh,
This is
this is fascinating.
yes. So this is our sun. This is the size of Regulus. Regulus is spinning about this axis. And so it because that's a very fast spin, it spins this gigantic object every 24 days.
No, that's the Earth. That's our sun.
It's sun, yeah.
A stun, yeah, every 16 hours. So thank you. So that is causing this to bulge out. And material that was out here has been thrown off. This is right out to the Roche limit for this star. Its shape is defined by the Roche limit. And this part of the star is farther away from the core. It's cooler because then it's called gravity darkening band around the equator.
Wow.
So
And that,
this is, yeah,
that's how it's turned to our vantage point of looking at it. It's turned on its side like that.
yes, it's
Mhm.
Sort of like
Like
our planet,
Uranus.
like Uranus.
mhm.
And it's spinning almost as fast as Jupiter is, isn't it?
yeah,
Yeah,
almost,
Fast spinner is Altair. I think Altair is around 12 hours to spin.
Yeah.
yeah.
Really fast.
And it's also highly distorted too.
Yes, yes.
Well, I guess everything out there in space is spinning, isn't it? Some at some degree. Is anything
Yes.
just sitting motionless anywhere?
Very hard to get these objects to be zero motion.
Oh, this is incredible. These pictures, my God, considering you can barely see the sun in the lower left.
Yeah,
God,
still
physics
down
is-
there. Is right there.
The laws of physics, the momentum is always conserved. So
This,
if you have
yes,
gases coming together, it's you got momentum with it, then the planet's going
Yeah.
to be spinning.
these
with
are
momentum.
like ice skaters that conserve momentum when they start with a big cloud that's barely rotating, and as they collapse to an object, they're much more highly rotating. But anyway, this is Antares, which
That's
is
the biggest?
also
Is that the
in-
biggest of all of them?
No.
no,
There's
No.
even bigger. There's even bigger than that. My God. Makes you wonder if there's exoplanets around those monsters.
Would be tough.
Take a while, but you'd have to really be out there.
Mhm. Some of these are quite large. These planets there would take up. This is an actual image of Antares.
So,
No kidding.
That's for radio astronomy.
Yes, it's a constructed image, you might say.
Well, is it on its deathbed like Betelgeuse?
Yes.
They're both ready to blow.
These big hot stars don't last long, hundreds of millions of years,
Or
A
even
mere
tens of
instant.
millions.
tens of millions.
So they just sort of collapse in and disappear and then come right back with an explosion, right?
Right.
That's how it works.
Also, Antares, Ron, has a companion star. It's really tough to see, but we cracked it actually in San Jose many years ago at the observatory we built. And I think we used a 6 or a 7, I think it was a 7-inch F9 Tom Back telescope.
Oh,
Well, if it's a companion that's a smaller star, like let's say a red dwarf, it'd almost be like a moon, wouldn't it? But you can't define it as a moon because it's glowing with fusion, right?
Yeah, it was a star. It was a
Well,
star.
I think it's a white dwarf, so it's not
Yeah.
doing fusion, but
It
it
was
is giving
hard.
out
It was
light.
hard to see, but we actually got it. We actually got that darn thing.
But
I've heard
something,
if you use an O3 filter, that helps you get it.
Mm-hmm.
but something this big, if it had a small star, this other star would sort of be orbiting it, wouldn't it? They wouldn't really
Yeah.
orbit each
Oh,
other.
yeah.
But you don't call them moons.
Well, they orbit each other in the same way the Earth orbits the sun and the sun orbits the Earth, you know.
yeah, they
It's
wrote,
just that the
they
sun
orbit
moves
around
very
it.
little.
they orbit around a common center of gravity. It's
Yep.
like a fat kid and a skinny kid on a teeter-totter.
But the bigger unit gets to go less out of its way, doesn't it? It has a little
Yes.
smaller circle.
It shows less motion.
Wow. Yeah. Have they found exoplanets around these giants?
I don't know that.
I don't think
There's
so.
over 5,000 exoplanets now.
Yeah,
Okay.
it's tough. It's tough run on these things because they're bubbly and boily.
Yeah.
And the easiest way to detect the exoplanets is by looking at the radial motion of the star. And if your surface of your star is moving up and down, that really contaminates your signal.
And there are theories, scientific theories as to how they got that big. They just gobbled up a lot of the nebula's gas and dust, or might it be
Yeah.
a bunch of stars colliding like they do when a
That
black
can
hole
happen
forms?
too. You get the blue stragglers in
Yeah.
the globular clusters, but it's more likely that they just form that way.
Yeah,
Yeah.
a lot more mass at the start.
Mhm.
Wow.
Yes. So this is a star. The next thing is a star that we show commonly this time of year to our customers out of our public outreach, and that is Alberio,
Oh, yeah.
centered
Yes,
here.
we're looking
in-
at Kachuma.
Alberio.
Yeah,
There's another one that sounds like that. Aldebaran.
Aldebaran,
Altair.
yeah, a lot of star names start with Al because it's Arabic for the.
Oh, that's true.
There it is.
Okay. All
this
right.
is called the Boy Scout star. I like to
Cub
call
Scout,
it the
yeah.
UCLA star. But these are the two components of Alberio at the end of what is it, Cygnus. And this is a blow up from a planetarium software. It's not a photo.
And the blue isn't as saturated as it looks in real life.
No, it's quite dramatic color. Now, a lot of people have trouble seeing color in stars. All stars tend to look whitish to them because the light level is so low. But if you show them Alberio, pretty much everybody can see the difference in colors on that.
And it goes back and forth as to whether these are a double or a binary star. And right now, from Gaia measurements, it looks like the pendulum has swung back to it just being a chance double rather than being gravitationally bound.
Okay.
Did I miss what the red line is?
No, that's the construct of the asterism of Cygnus, the swan.
Oh, I see. Got it.
Yeah, it's just the planetarium program putting in the lines for the
Yeah.
swan.
So we're looking at a binary, basically.
No, a double.
The double. Yeah,
They
these-
don't,
And
they
Ron-
don't orbit each other. Okay.
Yeah.
So
Well, you know,
that's,
when we see them,
It's the
they're
beak set.
like this far apart. You can't see my image, but anyway, when we go and see them, we see them like this. So they look close together, but one is about what, 30 light years away from the other one.
Oh, is that right?
Yeah,
and Ron, this is in the beak section of the swan,
right.
Okay.
the beak.
Well, Alberio is beak of the hen, isn't it?
It's weird. It's like a medieval game of telephone. It was originally called Beak of the Hen, but that in Arabic is quite a different looking phrase.
Mhm.
And somebody apparently, you know, when they're copying this stuff over and over during the Middle Ages, misspelled things and called it ab irio from something else.
Mhm.
And then somebody said, oh, well, that must be a misspelling of the Latin alberio. And so you ended up with alberio from something totally unrelated.
Right.
So this is, go ahead, finish. Nothing, okay. This is the asterism of the swan. And because it's a swan, it has a real long neck and a short tail. If this were the neck, then it would be a hawk with a long tail and a short neck. And these are the wings. But there's a lot of stuff in Cygnus, Pelican Nebula, North American Nebula, and down here the
Veil.
Lacework Nebula. I've never heard it called that, but and now I can't remember the real name of it.
The Veil.
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 Nebula, thank you. Yeah,
That's a
the
ski area.
Cirrus Nebula.
Those are
So,
like pieces of the Veil. There's the Pencil
Right.
Nebula and the Witch's Broom.
right. But if you have a wide enough field of view, it's a big, thinly defined arc or circle.
Did you call it an asterism? Isn't it a full-fledged constellation?
It is a constellation too, but the asterism, the shape that they're trying to mimic here is the pattern of these stars.
Right.
But the
cause-
constellation is whatever's inside these lines. And
You know,
everybody draws these lines a little differently, it seems.
It's too bad they can't find a jumbled, gnarly bunch of stars nearby and call it the ugly duckling. Kind of nice and Hans Christian Andersen.
Mhm.
Fascinating stuff. I love it. Okay. Here we go, our reverse horizon again, going the wrong
This is at
direction.
5 o'clock in the morning. You can see Neptune up there, way up there.
Okay.
And this is the tail end of the Southern Delta Aquariid meteor shower. And this is showing you in this region down here is showing you the radiant, where the radiant comes from, where the meteors appear to come from. It actually peaked last night or over the weekend on Sunday. And you want to look farther up around here to see the meteors that come in. So there should be a few of them, but unfortunately, this is a full moon day, so you're not going to have much luck seeing the stragglers.
Well,
We
we
do see-
saw some people at Refugio on Friday. Some of the campers saw a fair number, and when I was driving home around midnight, there was a really good one. It went south to north as I was, you know, I noticed it while I was driving down the freeway, so it was pretty bright.
You know,
What color is it?
what's really sad is that you can't use telescopes in any of this, can you?
If you see one in a telescope, you're just extremely lucky.
You're getting a very brief view.
Yeah. So in this morning star pattern, you can see Fomolo down here, which is a southern star.
And it's got an
And-
exoplanet, doesn't it?
This is a photograph of Fomolo,
Wow.
not part of the Beehive cluster.
Got the 4 spikes on it. There we are.
This
Okay.
is, this is taken from an Earth-based telescope.
Aha.
This is Fomolo taken by the James Webb telescope. The actual star is blanked out here because it's so bright, but it has this structured disk pattern to it of dust.
Hmm.
And in this dust pattern, taken with different infrared and deep infrared filters, are knots of gas that are in the process of collapsing, most likely, to
Exoplanets.
protoplanets, yeah, and then planets, exoplanets, yes. This line here is 80 astronomical units long. So
Wow.
this distance here, or this distance here, which should be the same distance, but this is foreshortened, but this is the one you compare the 80 to. And so that's about 40 is about there, and we would be way in here.
Yeah, this would be 80 AU would be like the diameter of our solar system if you count Pluto.
Yeah.
Mhm.
Oh,
And we still do, Chuck.
We still do, yes. Those of us with fond memories. So this is a comparison of the Fomolo system to our our solar system. Our solar system here is twice. So this one is a blow up of out to Jupiter. And this is the Fomolo system. Just this inner box blows up to this. Fomolo has a B component, a planet, which is believed to be around here. It's controversial. Some people see this knot that's already formed, and some people photograph it and they can't find it. It's not there. So,
Really?
yeah, so I'm not too sure, but there's enough crap up there. It could be a planet. But the picture you saw earlier showed all this. So this is much bigger than our planet, our solar system.
Well, yeah, but you could call this the Saturn of the stars. Are there any other stars that show these rings?
Oh, yeah, number of them. Some of them show them completely edge on.
And some of them show a complete, sphere of stuff, almost like our Kuiper belt or like our Oort cloud.
Yeah.
So any cellular system like the solar system don't get created all at the same time. Later on, the planets kind of evolve, right? They solidify after the sun's been created in the middle of the gas.
Well,
I don't know about that. I don't see why they wouldn't form at the same time. I mean, bigger objects take longer to form, but
Well, obviously, in this case, it's happening. We're getting new planets.
Well, the Fomolo is completely formed.
Okay.
yeah, and it tends to blow away all the smaller stuff. It's solar wind and the radiation pressure. So it kind of puts a stop to some of the planetary formation, but there's still bigger chunks out there like our asteroid belt that can contribute.
Yeah.
But these rings aren't like the same rings around Saturn. Those are pieces of ice and rock, right? This is gas and dust. We're looking at
this could be ice and rock and gas and dust.
Yeah.
There's a lot of
But
it.
also when the sun blows away the leftover gas and dust, it will set up eddy currents in that disk that could then facilitate a collapse of smaller bodies.
Getting new moons, new planets. Gotcha.
Possibly. I'm just guessing.
How are we mispronouncing that? Fomalhaut?
Oh,
I
you'll
do
see Fomalhaut, Fomolo, Formalhaut. There's all kinds of.
The University of Texas has this little blurb on the radio periodically, and they call it Fomolo. So that's what I've learned to do.
Tom,
It all depends where you put the emphasis.
Yeah.
Tom Whittemore,
Ron,
you got
Ron,
married there, Tom.
I grew up, Ron, mispronouncing it as Fomalhaut.
Fomalhaut. That sounds like
Okay,
a Dickens novel.
Yeah.
Okay.
Don't forget, Ron, information's 11 years old. I hope that star's still there.
Yeah.
Okay.
I would be alarmed if it wasn't. So this is August 3rd at 3 a.m. This is the pattern you're going to see in the moons of Saturn. If you look, Titan will be easy to see. It will be way out here. It's about 8th magnitude, as I recall. The rest of them are much fainter, about 12th magnitude. You're going to need a bigger scope to see those.
And less turbulence. We had a lot of turbulence up at Kachuma.
The what?
We don't
I
call
said, and less turbulence in the atmosphere to be able to see this clearly.
Yes.
Saturn was pretty wiggly at Kachuma.
But it is definitely, we're getting ready to go through a ring plane crossing, which will happen in March of 2025. And when we do a ring plane crossing, the rings are so thin, they disappear for a couple of hours.
Yeah.
And already when you look at Saturn now, the ring looks more like a line than like an actual ring. It looks just like a line going through Saturn.
It's represented here as it is.
Yeah.
I wonder what the ring spacing was looking like, or the ring tilt was like when Galileo first looked at it.
He looked at it near a ring plane crossing, and he also looked at it during a ring plane or very close to a ring plane crossing where he couldn't see the rings.
Yeah.
So he was really confused that they were coming.
Those have happened every 14 years, right, Chuck?
15, roughly.
15 years.
Between 14 and 15.
But do we ever see Saturn from above, just like a bull's eye on a?
No,
never that way. Okay.
Only with Cassini's eyes.
yeah.
So it's always on an edge of some sort. Got it.
Yeah.
Pattern of Saturn. I love it. And here's
Okay.
old Cynthia. Cynthia, the moon, lunar time.
This is our moon today. It's full almost right there. So you can see pretty much all that. This shows a little, this is a map of the moon. This is not an image of the moon. So this shows more crater features than you will actually see on the moon. What you will see are these ray systems, these bright rays. And there's a bright ray system out of Tycho down here that completely dominates the moon at this time. It's unfortunate the map doesn't emphasize it, but it makes the moon look like a peeled orange to me. So all these things going on.
Yeah, Jerry, this full moon's in Capricorn, so it's got a nice, low arc, if you like, in the sky. So it'll scoop up a lot of that atmospheric red that you're talking about.
It's going to turn full almost exactly 24 hours from right now.
Tomorrow morning, huh?
Yeah, I believe so. Yeah.
Well,
There's a nice contrast on the moon between two big craters. One is Tycho, which has the very straight rays because something hit it at high speed.
Right
then you
there.
have Copernicus, which is up a ways, that had a low speed impact, and you can see the ejecta kind of tumbled. So the rays are not straight; they're all wiggly.
Where do you suppose future generations, the colonies that are going to be there, if we survive, going to be out on the mares, the seas, or in the craters?
Well,
They're
they're heading to
the
the
South
South
Pole.
Pole because in the deep craters where the sunlight never reaches, you have water ice. And so
That's
they're going to
important.
be burrowing down under the ground. So I think they'd prefer places where there's stuff like lava tubes.
The moon got its water delivered pretty much like we did with inbound meteors, right?
Yeah. And
As far as
comets.
I know, that's still an open question exactly where we got all of our water. There's no single source that matches the isotope ratio of Earth's ocean water.
Yeah, it seems to be a combination of what we see in comets and what we see in the minerals in meteorites.
Well, I have heard that the heavier metals, like your gold, came from space, probably because the gold that's so heavy, it's down in the middle of the earth, right?
Everything came from space.
Yeah.
I know that. But gravity, as
Gravity
far
sucks.
It sucks you.
when did I lose
Okay.
control, Mr. President? All right, go ahead.
This is August 3rd, 9 p.m. The moon is just about to occult this seventh magnitude star here. You see magnitude 7. The moon is moving this way, or moving actually, the moon is moving that way, and it's
Should
I
move
think
to
it's moving more right to left, but
it
Yeah.
moves more to cover this one because it's going to cover this way. I played with it back and forth so many times that my brain remembers moving it this way. But that was not what's going to happen. It's going to cover this and cover it over for probably, I don't remember the times, at
about
least
an hour, I think.
Yeah.
So this is a few days after full, huh? So
Yes, you can see it's just a little bit.
so the moon will probably be in Aquarius by then.
Yeah, I don't recall I don't recall the constellation there.
Probably
But you'll know the star. It's SAO 146663.
Yeah, that's an old friend.
Yeah.
Hmm.
And this is what the moon looks like. The map of the moon looks like later this week, about Friday or Saturday. So it'll be a waning
one thing,
crescent.
this is probably not going to happen for this star, but one thing about these lunar occultations, they used to use lunar occultations, especially grazing occultations, where it just barely skims along the edge of the moon, to map the topography on the moon before we got satellites orbiting the moon that mapped it really accurately.
Uh-huh.
But they're still used today because the occultation or the grays can tell you if it's an undiscovered double star.
Oh, yes. Yeah.
And actually, one of the occultations I did, not with the moon, but with an asteroid back in December, the results just recently got put up and published. And I was like, what's taken so long? Well, it turns out there was structure in the light curve, and it was an undiscovered double star.
Okay.
Undiscovered all this
Back
time.
in the 60s, there was someone that published in Sky and Telescope a light curve of an occultation of a star, and it showed the characteristics of diffraction pattern of a point source going behind an edge.
Yeah.
And I thought that was pretty cool. But it would be different if it was a double star, yes.
So
Well,
this was a star that got occulted by an asteroid, Ron.
Oh,
And from looking at the pattern of the light curve, it was actually a double star. They hadn't known it was double before that. You know.
well, my understanding is more than half the stars up there are doubles. Is that what you're saying? A
Well, that's
binary?
binaries. That's
Binary.
binaries. But this was a case of a probably a spectroscopic binary that couldn't be resolved, or just a very close double that wasn't resolved by a telescope, but it was resolved by the occultation.
How do you define a double star? They just happen to be close to each other, but they don't orbit.
Yeah, they just happen to line up from our point of view.
Oh. Well, does the moon, when it fills up, really screw up astronomy, or just in that part of the sky? The eastern sky would be like a street light, but how about the rest of the sky? It wouldn't affect clear over the other side, would it?
Sure it would if there's water vapor in the air and stuff like
Yeah.
that.
Oh,
At Kachuma, we had, reasonably high humidity and things to the north were clear. But stuff around the moon was just washed out with
yeah.
light pollution.
When the 2 weeks between first quarter and last quarter, I generally do not get any good usable photographs. Sky is too bright.
it wouldn't affect the web, would it? Because the web's out 4 times further than it.
Yeah.
It's only full to us, but not to the web, right?
Right?
Amazing.
Well, also their light shields block the moon. Because the moon is sort of in the same direction as the sun with respect to the web.
Yeah.
Wow. Well, then all the astronomers of the world focus on the moon when it's full moon time, I guess, pretty much, don't they?
Now, this
They
moon
catch-
later
they
this
catch
week,
up on their sleep.
One of the quarters where stuff is side lit and gives you a lot more definition.
yeah, there'll be a lot of good stuff to image and look at around this terminator. I'll probably out to here. See these very nicely.
Yeah.
Okay, this is a photograph taken from Apollo 12 from the command module as it orbited the moon, while the other astronauts were having a picnic down on the moon. And this is Copernicus over here.
Wow. Is that a real picture?
Yeah, it's the real photograph taken with a Hasselblad camera
No kidding.
and on film.
Yeah, 2¼ inch square film.
Yeah,
Well, I want to see one like this of Clavius, where they dug up the monolith.
they have them. They
Do
did
they?
extensive photography, but there's no people there digging up anything.
Oh. I love it. Okay, where are we now? What part of the sky is this?
Boaties.
State Sextet, Corona Borealis.
Yeah,
Heard that term before.
group of galaxies, Ron.
Asterisms are us.
Mhm. Now, because the moon is in the east, we're going to look in the west, and we're not going to look for faint fuzzies. We're going to look for star clusters. And this is the star cluster M3.
Beauty.
Near Booties, it's in Canis Venatici,
Mhm.
near the star Arcturus. This is a representation of the size of Arcturus, which is a red giant star.
Here we go again, comparison.
Yeah, and this is Antares. This is Arcturus,
Yeah,
star in Bootis. And this is our sun bringing up the tail end again.
Jeez.
Some big stuff out there. This dotted line is the orbit of Mars drawn on the representation of Antares.
If it were in our solar system, yeah,
Yes.
red giant.
And this is a wide field view of M3. This is the way it would probably look in one of our outreach telescopes. Except you wouldn't see all this detail, direct vision, but you can see it if you use averted vision to look at this stuff. So if you kind of squint a little bit, that's what you would see in this, telescope.
Really?
So
And
these are
another cool thing up by Arcturus for binoculars, if you look around, cruise around there, there's a little asterism called Napoleon's hat.
Yeah.
It looks like a little peaked Napoleon or Admiral's hat.
Oh, just the hat.
Yeah.
where is it from Arcturus?
Oh, I'm so used to looking at a telescope with a flipped view and
Oh,
stuff. I couldn't tell you exactly, but it's pretty close. It shows up in binoculars.
okay.
And it's an asterism.
Yeah.
Yep.
What percentage of the night sky stars are these giant monsters? Only a tiny little dinky one
Oh,
out.
the red giants and stuff.
Yeah.
They
tend to
don't
be
last
bright.
long.
Is that what the problem is? Well, but there's red dwarfs everywhere, right? That's the
Yeah.
majority of
Yeah.
stars, right? Although I don't know how many of them we can see.
Right. That's the problem. The red dwarfs are dim. They last a long time, but they're dim.
Yeah.
Chrysalis garnet is pretty nice to look at.
Yeah, but that's not a red dwarf. That's another red supergiant.
Oh, okay.
The red applies to both the giants and the dwarfs, meaning they're not as
Red is cool.
They're
cool.
cool.
Hot, yeah.
Cool. This is white. The stars here are white. They are very old. They're not big stars. They're not giant stars. Their distribution, this is the HR diagram for a globular cluster. Matter of fact, it's 4M3. And you can see the stars are down here in brightness. They're not very bright, and their color index is not very red. So then it gets, some of them get red up here, but these have short lives. They may have formed by collision or something, but most of the stars are down in this area. And you can see the difference because this is a comparison of globular clusters populations to open clusters populations. And you can see the globular clusters have a lot of these old dim stars. And the open clusters have a lot of young bright stars.
And
These
bluer.
are stars that have just contracted or condensed from the dust and gas in the galaxy.
So the old red, they're red, right? The old ones, the old dim you
No,
talked
the
about.
big ones are red. The
Big
old
ones.
ones can be white dwarfs.
Is there such a thing as a red star in between dwarf and giant? Let's say the size of our sun. Our sun's not a red sun, but it's
No,
not
our sun's
dwarf.
a yellow star, so we would be in this band here.
And the yellows are the ones that last.
So we would be about here in an open cluster HR diagram.
In general, Ron, the more toward red you are when you form, the longer you live. But when you go on the main sequence, but when you're a really bright blue star like that, you live fast and die young, and you transition over into the red zone before
Yeah.
bad things happen to you.
The bright blues become giant reds
Yeah.
over
Yes.
time. Is that pretty standard?
Yeah.
That's how Betelgeuse used to be. It was a bright but smaller.
Yes.
It was a big, massive star. It burned through all of its fusion relatively quickly, and it's about to reward us with a supernova.
Tomorrow.
Yeah,
After
after
midnight.
midnight. This is also August 3rd, 2:45 in the morning. Io is just about to come across Jupiter's disk. There's 3:05. This is Io's shadow, and it's going to move across this way. So if you want to see what do they call it, an occultation or a transit?
Transit.
Transit.
We're going to skip this and go right, because we have so little time, go right to a very fanciful one. We'll come back to the atmosphere if we want. This is a science fiction concept called an O'Neill cylinder, where someone has built a giant transparent cylinder in space. See planets back here, and it's spinning, so there's gravity, and then they put dirt and soil and water in it like this. And as long as no one punches a hole in the thing, everything goes fine. And you can live down here, and it gives you a tremendous surface area in here. But you can't, I mean, where are you going to get this stuff? You can't bring it up from Earth. It would take everything on Earth to do that. But a proposal was sent out by NASA in the 60s and thought about for a long time, how would you build a habitat in space using an absolute minimum of material brought up from Earth? And a very fanciful thing was published recently, how to do that. And this is the artist concept of it. And it's called a reverse O'Neill sphere. But this is a carbon fiber
Mesh.
bag
Yeah, or net.
that was
Wow.
put up in space. And it was originally wrapped around an asteroid like Dimorphos that is about a 300-meter diameter rubble pile. And then they center it in, this is not a sphere, this is just actually like a tire. It's open at both ends. So then they put the tire out here, and then they spin the whole thing up, and they make the asteroid spin. So the asteroid, and it can't hold itself together at these spins. So all the crap that makes it up spreads out because it's now beyond the Roche limit, and it populates the inside of this big wheel. And that there's enough density there that it now protects, at least for radiation coming in from the side, it protects any habitants down there from cosmic radiation. There's no atmosphere in here, but there are buildings now drawn in here, and the buildings would have to have their own contained atmosphere. But this would solve one of the major problems of space travel and space living, and that is zero G. So this would continually rotate then at giving you a 1G surface down here.
Well, you have
Pretty interesting and wild concept.
a set of engines that spins it up.
What the word escapes me? I'm trying to the force involved is what starts with an A.
Centripetal force.
Centrifugal sport. It seems to me, I imagine these things in my brain, gentlemen, and you could be floating in the middle of this and not on the edge, not be affected, not get the fake gravity. You could still be floating.
That's true.
So
Unless one of the spikes hits you, one of the spokes.
what if you were on the edge, being pressed against the outside as it's turning? You got your artificial gravity, and you ran against the direction of the turn as fast as you could and jumped up into the middle. Would you just stay there, you suppose?
No, it depends how good a jumper you were. This would be spinning fast enough that you really wouldn't notice much different from 1G here on Earth. But there'd be an elevator.
At the equator, the Earth is traveling about 780 miles per hour.
Yeah.
About 1,000, right?
Yeah.
Oh, really? Okay.
1,000. So
At
you're
our
not gonna
latitude,
run
it's about
significantly
700.
against that.
Oh, okay. Yes.
Well, what if
And Ron, just think of this, it's 1G directed outward from that central thing.
right?
So if you were out here on the edge of this ring, you'd be feeling 1G acceleration outward. And if you took a step right off that edge, you'd probably go flying away from
That's
this.
right.
ring.
You'd go
I'm
flying off in a tangent.
I'm not talking about the edge. I'm talking about the interior.
Yeah.
Where there is no gravity. The gravity.
That's right.
No. There's no you'd only feel no acceleration if you were right at the very middle there.
Right. And
There's
see,
still
that's where
gravity.
the spaceport is.
Yeah.
Well, you could be halfway out between the middle and the edge and still just float there in space as long as you weren't being flung around in the circle.
Now, if you were in this tube, which I assume is an elevator, you would feel half of Earth's gravity right there. This
Oh,
is
I see.
analogous. This is analogous to a tunnel dug through the Earth. At the center of the Earth, there is no gravity. Out here, there's a gravity about half the surface normal, and out here at the surface, it's about 1G.
What if you threw a baseball?
Yeah.
Would
There
it
we
go
go.
straight across? Just be outside of the
Well,
force?
you'd have to be able to throw it at escape velocity.
I'm talking about to the other side. Would it go
Yes.
straight across,
No.
or would it make
No.
the curve like it does on Earth?
Run. You'd have to be able to throw it faster than that, so that it would overcome the 1G. So it'd be like trying to launch something into space from the surface of the Earth.
Right. Ron, I was gonna
Yes?
say, if you had that baseball and you put it in that tube and you started it going, okay, it would go up and down, up and down, up and down, about 90 minutes at traversal.
You mean it would go back and forth like an
One
early?
G.
Early.
Well, that's I actually I think that's not what would happen, right? That's what would happen if you had a solid Earth and you had a tunnel like that.
Right, right.
Because then the gravity would act as though it were at the center. But here, it's not really gravity; it's artificially induced
It's phony.
acceleration. Yeah.
Right.
It depends how fast you threw the baseball.
What'd you say, Bruce?
It depends how fast you threw the baseball. If you threw it up in the air, it might just do a parabola and come back down near where you were, because you're rotating and it's now no longer rotating. It has whatever the momentum it had when you released it from your hand.
Yeah.
If this is 1G at the surface, then it would be the escape velocity of the Earth, which is 11 miles per second. So if you threw it upward at 11 miles per second, then it would not see this 1G. It would just go on forever and smack into the other side.
Would it stay
But
on
no,
the?
And you couldn't do that.
I was going to mention, Chuck was correct. If you took a big drill and you drilled a hole right through the center of the Earth and you dropped something from the top, it would go back and forth in 90 minutes, just like a satellite at the surface of the Earth.
Exactly.
Yeah.
Do you suppose Isaac Newton knew about all this and could
Oh,
visualize?
God, yeah. He invented the physics.
Yeah.
Well, I know that, but he wouldn't imagine something like this, would he? Or maybe he did.
Oh, this? No,
Yeah, I mean, back in those days, you could take a bucket full of water and swing it around your head and it wouldn't spill on you.
You can still do that today.
Yeah.
When I was a kid, it didn't work for me.
Yeah.
Well, it's part of the reason they stopped putting those little carousels in playgrounds. You notice those have gone the way of those.
Yeah, people would fall off and they'd get underneath of it.
And the teeter-totters are gone and they're having trouble really coming up with stuff that kids play on. We did it again, guys. I like to think I had something to do with this. I'm the man that does the stupid questions and we'll do it all in a week. In fact, I think in between now and next week, we have a nighttime meeting inside that big auditorium. Museum
Next
of Natural
Friday,
History.
right?
Your old friend, Dr. Peter Love, is going to be talking about the web and giving us some of the latest photographs and maybe talk about those 6 distant galaxies we kicked off this program with. Anything in between, Chuck, that we should know about before we go?
Thursday is Bakara.
Okay.
We're going to go back. We got sprinkled on 2 weeks in a row. So we were kind of saying, well, we're not going to come back and get our telescopes washed. But it sounds like they're gonna adjust their sprinkler schedule.
Oh,
But that's the only outreach between now and the meeting. But Saturday is then Kachuma on the 5th.
okay. And then a week after that is a star party, and we're in the middle of the summer, and the heat wave has arrived, and that's been the Santa Barbara Astronomical Unit SBAU Astro Hour for July 31st through August 6th. We'll see you next week. In the meantime, show up Friday night at the museum, and thank you for joining us. We love doing this.